Alright, welcome to another thrilling installment of Calculus with Keller. Today we're going to be working on the second half of section 10.1 using trig identities, and we're going to use them in a little bit different way than we did in class. We're going to use them to substitute into some other kind of problems and to get a solution through that process. And really, we'll get right into it with some examples. So the question is going to be worded something like this when you see it on in a homework problem or in a quiz or a test or whatever. It's going to tell you to substitute a certain trig expression. So in this case, 2 times tangent theta. And we're going to substitute it into this radical. And when we do that, we're going to get a certain trig answer. Alright? And so the whole work with trig identities and things like that we did today in class, that will come in here in a moment. So first step we're going to do in this process is just plug in 2 tangent of theta and plug that in for x, rewrite it, and then do any kind of simplifying you can with that expression. So obviously as you plug it in, you're going to get 4 plus, and you square that whole expression, you get 4 times tangent squared of theta. You might notice there that I can factor out a 4 out of each part. That's going to leave me 1 plus tangent theta, tangent squared, excuse me. This is where the trig identities is going to come into play. You'll notice that 1 plus tangent squared, we talked about that I'm sure in class, is the same thing as secant squared. So I can rewrite that as 4 times secant squared theta. And it's so important, and at least until you get a lot better at these substitutions, that you keep those blue sheets handy. Now this is a lot easier to take the square root of. I have a hard time taking the square root of 2 separate terms like I had earlier, but this is pretty straightforward. The square root of that is 2 secant theta. And typically when you get problems like this, you're going to be given a specific domain to work with. Typically it's going to be like from negative pi over 2 to positive pi over 2. And so that will help you determine a lot of times whether your answer is positive or negative. And in this case we won't worry about that too much. We'll just say this is 2 secant of theta. Also remember, you didn't incorporate the square root sign in there. It was already in there in the first place, so you usually don't have to worry about positives and negatives when it's already there. So now that you've seen it, go ahead and try one on your own. See if you can understand the process, how you plug it in. Once you see the problem, hit pause on your video, try to do the work, and either when you're done or when you get stuck, go ahead and play it and see how you do. Okay, so we're going to use the substitution of x equals 2 times the cosine of theta, and we're going to plug that in to the square root of 64 minus 16x squared. Have fun. Alright, so hopefully you've had a chance to work on that, and so we'll go through the same exact process that we did a few moments ago. We're going to take that trig expression, we're going to plug it in. Squaring that's going to give us 64 minus 16 times 4 cosine squared theta. Multiply that out, 64 minus 64 cosine squared theta. Again, you'll notice that you're going to factor that 64 out. When you do that, you're left with that 1 minus cosine squared in there, which hopefully you recognize now as sine squared. We've seen it a couple times earlier this year, and I'm sure we saw it again in class. So 64 sine squared, which is the square root of that, is just 8 sine theta. And again, we didn't put the square root in this problem, so there's no reason to worry about a positive or negative. This is going to say different things on the screen right now, like sine is positive here or there, but really bottom line, that's the reason that it's positive. It's positive because we didn't incorporate the square root. Any time that you're given a problem like this and the square root is already given to you, it can be assumed that you're looking for the positive answer here. Alright, don't get caught up into when is sine positive or cosine negative or anything like that. It really just boils down to the fact that the square root is there. Since the square root is there, we're going to we're going to just look for the positive solution. Now in a few moments I'm going to give you an example problem where you bring the square root into the question, and when you do that, then of course you do have to bring both the positive and the negative solutions along. But for right now, since it was already there, just positive 8 times the sine. So our last thing we're going to look at here tonight is a little bit of a different kind of problem. It's not going to be an expression now. It's now going to be a trig equation, which really the only difference there is you have an equal sign now. And so on the other side of the equal sign, you're going to have a number. And so when you solve this, when you do the substitution and you solve it, you're going to have to go one step further now and figure out what angle actually makes this problem work. So the question looks something like this. Again, you're going to have a substitution to do. You're going to plug in 6 times the sine of theta, but you're going to plug it into an equation now, like I said before. And really on the screen that should say equation, shouldn't say expression. And you're going to plug into 3 equals the square root of 36 minus x squared. And when we're done, we're going to look at both finding the sine of theta and the cosine of theta. And we'll talk about how you do that here in a second. Again, that's just a domain, helping you understand that we're talking about the right-hand side of the unit circle, those numbers from negative 90 degrees to positive 90. Step 1 in this process is exactly like it was before. Take your trig expression and plug it in for x. You'll see that work looks very similar. Square that, you're going to get 36 minus 36 sine squared. Again, you can factor the 36 out, making it much easier to take the square root of this pretty nasty looking square root problem, radical problem. That's going to be 36 times cosine squared. Square root of that is 6 times the cosine of theta. And again, that square root was already there. No reason to worry about a positive or negative here. But now we're going to work on solving this for theta now. Remember, we wanted to find what the sine of theta and what the cosine of theta is. So finding cosine here shouldn't be too difficult. And again, I'm just trying to give you another reminder, not worrying about whether that's positive or negative right now. Alright, back to the problem here. Solving for cosine of theta. Remember, that's one of the questions that was asked of you. So if we just take that 3 equals 6 cosine theta and divide both sides by 6, reducing that's going to give you cosine of theta equals 1/2. We actually could figure out what theta was if we wanted to. We could figure out what angle actually has that if we wanted to do that, if that's what the question was asking. But we'll just keep going here. We're going to look for sine now. You could do sine a couple different ways. If you wanted to build a triangle for this problem, you certainly could. We're going to continue to use the trig identities that we've learned in class here this last day or so. And we're going to use the Pythagorean identity, one of those. And the one we're going to look at is sine squared plus cosine squared equals 1. And so when you plug that in, plug in what you just figured out just now. you just found out that the cosine of the angle was a half. So sine squared plus 1/2 squared equals 1. Simplify that to a fourth. Subtract it to the other side. And you get sine squared equals 3/4. Now, you are introducing the square root now in this problem. So that means you will need to have both the positive and negative solutions to this problem. And so the square root of sine squared is just sine. And the square root of 3/4 is now going to be positive or negative square root of 3 over the square root of 4, which we can simplify to 2. And so that's your solutions for this problem. The cosine was 1/2, and the sine is now positive or negative radical 3 over 2. If you want some more examples with this, we'll spend some time in class tomorrow, but you're also going to be doing some of the problems that you did in class as well. So if you want a little more time with this, on page 652, you can look at problems 89 through 97, any of those problems, but if you want to do the odd ones, they're also in the back of the book. Okay, see you tomorrow. Bye.